C7, 8, and C 1, 2, 3, 4, 5, 6, 7, 8. This, for example, hemagglutinin gene encoding, this is neuraminidase gene encoding. H1 and 1. Here this will be H2 and 3, why not? So, what everything will be mixed together randomly. And here they are possible reassociations of these segments under the same capsid. Various versions are possible. You can imagine how many replacements can be found, but some virus can be found, like for example, H2 and 1 and H1 and 3. Moreover, people, if to look through this like nascent newly created viruses, moreover, you didn't hear that they were pandemics caused by these viruses. That's why these viruses appear to be hypothetically totally new for human population. It means only one thing. First, this is the excellent candidate for pandemics because our population, or so-called herd immunity, didn't meet these viruses before. Maybe someone has some, because anyway, I think you also understand that hemagglutinin is large molecule, neuraminidase is large molecule. Maybe specific changes here there, maybe these parts are common between hemagglutinins, and antibodies against this part may block everything. Who knows? It will be broadly neutralized antibodies. But in reality, if new virus appears, we have no immunity, chance for global spread of this disease, and with much more maximal victims. Is it clear? Okay, let it be so. So this is shift. Now the mostly difficult question. Concerning neutralization, what was the question directly about neutralization?
What is the mechanism that we use, like identify one?
Okay, let it be so. It means I have to remove one of my key questions from today's class. Okay, listen to, from the very beginning. So really, usually, this class should be devoted, of course, to each infection, of course, to COVID-19, due to its like emergency, urgency, and so on, and then at least fresh infection. But people, as we have no time last class to discuss laboratory diagnosis of viral infection, we will discuss nucleides, because the excellent example to apply all methods of laboratory diagnosis. But if you ask, let's begin to think about, first of all, who can tell me what is identification of virus? Not indication later, but identification.
Check the presence of virus.
Why? To find subtypes, maybe finding what. So, okay, I will come from another side. So, what is the last official level of international classification? Last means bottom.
Species.
Even species. For most of viruses, concerning species subject of discussion. Species. So, okay, and there are no any subtypes in these classifications, anything, because variants, types, strains are like informal units, practically used, but not officially adopted. First position. Then, who remembers the official definition for species? It's group of viruses, different age group of viruses.
Monophyletic
group, who remembers what it means?
From a common ancestor.
Because they have common ancestors, so that's why we have to make, or we have to attach this virus, or insert this virus, better to say, to some phylogenetic tree. It should be like from common progenitor somewhere at the top, and all the viruses are generated from it. So that's why we have to prove that virus, unknown virus where related, should be the member of this tree, or like identical to all the rest of representatives. So people. As it is so, which methods are used for identification of virus into species?
Genetic sequencing.
Genetic tests, and to be totally correct, it will be genetic sequencing. Genetic sequencing that should give us all the sequence of nucleic acid. So people, and its official position now. Possible to substitute, or maybe of almost equal power will be PCR to multiple genes. So not need to sequence everything, but the most important genes, like for example PCR for hemagglutinin for neuraminidase or something, if you want. Of course, by the way, if you make total sequence of hemagglutinin and neuraminidase of virus, we will get subtype, because everything will be visible. So, people, but, as I said, practically, to make sequencing of everything, it looks up to this moment impossible. It's subject of maybe nearest future. So that's why this is genetic identification. To finish with it, which methods are used for genetic identification?
PCR.
Sequencing if available, and don't forget sometimes possible hybridization. That's why what follows from this one? Need to revise this test. This will be hard. Okay. So people, but my standard comment to all this previously say that for more than a century, all the viruses were identified some way without any sequencing. And you said needs to identify subtype. Well, that's my question. What does subtype depends on?
And
Antigen extraction. This single position indicates not like totally now legal classification. Because total classification based on antigens, then the rest. So here it's based solely on antigenic proteins. Okay. So which tests help us to determine viral antigens? Well, some of them are rapid tests.
serological.
No, serological reactions, right? Which ones?
ELISA.
Immunofluorescence as rapid test and ELISA
ELISA
test as well. So people simply recommend you to remember that rapid tests for virology will be the same. PCR for genome and ELISA for antigens in some fluid or directly infection of the cells infected by virus immunofluorescence by antigens again. So here's the answer. But people and moreover, such tests like ELISA and immunofluorescence, it's not like common rule, and usually these reactions are not used in practice, but theoretically possible to imagine that if you take type-specific or subtype-specific sera, we can detect not only the presence of virus indication, but directly determine its subtype in one reaction. But as I said, for many reasons it's not used. We simply detect by immunofluorescence and by ELISA test, but possible. So people, then goes so-called neutralization. We come to the culture of virus. In which models the culture of virus is performed?
Embryonated.
Embryo, cell lines, and if possible, laboratory animals. So classical culturing, or maybe standard, most of all to say, standard cultivation of virus now in cell cultures. So our task to find subtype of virus. And when we speak about growth of viruses in cell culture, or in chicken embryo, anywhere else, now there are two steps. One is preliminary, secondary is final. Indication and identification. What is indication of virus?
Presence.
Detection that virus is present. Okay, what is identification? Determination not only the present, but its subtype. Our case. Concerning influenza, for example. Going next. It depends on properties of virus. What are the reactions used for indication of virus?
Hemagglutination.
Virus carries hemagglutination, they can produce hemagglutination and detect the viral presence. One thing. So people, by the way, can you agree with me that 2 correct words is twice more better than 1 correct word? Right? When you are at the exam, you are in doubt what to speak about, but you have some information to pronounce 2 words better than 1, right? So, okay. And to make your speech more longer, more rich, more beautiful, picturesque. So, that's why people. Who can tell me? For influenza virus, traditionally this reaction is not in great use, but it's also possible. For some viruses, it's like almost like the same level of importance like hemagglutination. So people, if virus has hemagglutination, it might be done hemagglutination, and what is one more reaction?
Inhibition.
Hemaabsorption, definitely so. It's typical for parainfluenza viruses of today's topic, have some here. And for respiratory syncytial virus also. People, that's why. For indication, if virus is hemagglutinin producing, it can be used as well as hemagglutination, but why not to use hemaabsorption? Here it is hemaabsorption. Some cells infected by virus with attached erythrocytes, usually of chicken origin or anything like this one. So, people, I have to say why this reaction, like only for some prominent viruses used, because difficult for performance. Need microscope, need like cell culture growth, hemagglutination much more easy. But this reaction can be done. Hemagglutination, hemaabsorption for indication. So, alright. What does the virus do in cell cultures? Topic mostly of our previous class. What does it do in cell cultures? Which cell culture to show? Oh, this is normal cells. For example, of course, schematically, if you look into microscope. don't invent something. Everything looks simple, but sometimes very long. So we drop virus into the cells, what will happen? Destruction. What is the official name for cell destruction under the activity of virus?
Lysis.
Cytopathic effect. And there are, like, I can't say dozens, but many versions of cytopathic effect. One is lysis undoubtedly. By the way, concerning lysis. Look, here it is special culture well played, where cell cultures as monolayer, I don't know, have a picture of monolayer or not, but trust me, this plastic, possible say back, plastic flask, is covered by monolayer of cells and cultural medium is here. And you see some empty spot due to the local lysis appeared in this monolayer of cells. What is the name for this active spot? Who remembers? Previous topic class. Plaque. P-L-A-Q-U-E. Plaque. So, this plaque formation, one kind of cytopathic effect. Who can translate? You are a specialist in Russian, I know. Who can say, who can tell me about what does mean образование?
Education.
Education. I understood you're a great specialist. Making of. Образование means creation. And включение.
Inclusion.
Well done. This is making of inclusions, one more kind of cytopathic effect. Next one, here it is lysis, already mentioned. People, today's topic, not influenza. What is the kind of cytopathic effect typical for example, measles virus, morbillivirus of measles? Simple, no time, symplastic formation. For respiratory syncytial virus, the same goes, syncytial formation, and so on. Like left side here indicated round in your cells. You may invent anything. Or everything of that will be cytopathic effect. Okay? Summarizing, indication is done by hemagglutination. In cell cultures can be done by cytopathic effect. So people, now the key moment, identification of type or subtype or more correctly serotype of virus. So people, if indication is done by some harmful activity of virus like hemagglutination, like cytopathic effect, identification will be done by prevention of these reactions with type-specific antibodies. Yes, or antiserum in real life. Antibodies might be isolated, might be no subject of discussion. So that's why people, hemagglutination, if you apply type-specific, this will be today's subject of today's laboratory work. If you apply type-specific antibodies, there will be no hemagglutination, there will be no hemagglutination, inhibition of hemagglutination. Who remembers what is the reaction that blocks cytopathic effect? What is its official name? By antibodies, by type-specific antibodies. Neutralization of cytopathic effect. Please remember that. No, I am addressing to them. Is it clear? A little bit. So, summarizing people. When students understand that, everything goes almost automatically. All the time I emphasize that not genetic, but usually no one speaks about serological identification. Type-specific identification goes, subtype-specific goes. If indication by pathological activity of virus like hemagglutination or inclusions or plaque formation, identification goes by prevention of this effect by specific and type-specific antibodies. In hemagglutination will be inhibition of hemagglutination. In cytopathic effect will be neutralization of cytopathic effect. In all these versions, by the way, chicken embryo, indication by death of embryo, identification by prevention of death of embryo. Here it is formation of inclusions, prevention of inclusions, and so on. Generally known like neutralization of cytopathic effect. Is it clear? Okay, let me do so. So people, I think we discussed the line next. Fluid and
Serum.
erythrocytes. It's not that simple question. Will be hemagglutination in control? On all the you ask, should be hemagglutination in control? Yes. Why? Because virus with its hemagglutinin clumps erythrocytes. So one erythrocyte, second erythrocyte. Between them will be virus with its spikes. It binds to erythrocytes, we see clumping. So that's why in control we expect to find clumping. It's like if control will be something else, will be something unclear, all the reaction is bad. Now, coming back to the reaction. Virus and serum, H1 and 1 or H3 2 doesn't matter. if if virus has hemagglutinins that match antibodies, antibodies will become bound to hemagglutinins, covering virus from outside. So, and we add the erythrocytes. Would be hemagglutination or not?
No.
No. Why? Because
Because
viral hemagglutinins were blocked.
Wow.
Yeah? Is it positive or negative test? Standard trick question.
positive. Positive.
Positive, because we found the virus. Is it clear? Negative test look like this one. Virus with its spikes, but antibodies are free. They don't bind virus because they are not reactive. If we add erythrocytes will be bound. Hemagglutination, but negative reaction. Understood? Stand up and surround my table. I stand here, I will bring the results over there. I need only white background. Who remembers? Positive test, but say no, I'm wrong. Hemagglutination is look like umbrella. And we said that in control should be hemagglutination. Not looking like this one, but some hemagglutination. So people, but so here they are from bottom much more visible. Here they are two controls looking like hemagglutination, right? So controls are normal, we begin to check the rest. How many positive wells in first row at the top? Two. How many positive rows in second line? Five. So that's why. Indicated. So that's why your opinion, if in first row 2 positive, in second row +3, 5 positive, what is the virus? H1 or H3?
Three.
H3, because the reaction goes much more longer than for H1. By the way, why some in high concentrations of antibodies, H1 and 1 might be positive? Due to the cross reaction. Antibodies are not absolutely specific. They, in higher concentrations, they react with many options, but in specific concentrations, they react only with specific target. Understood? Let it be so. Sit back and we'll indicate the results in our